Today I'm going to be reviewing the eco-worthy 100 watt bifacial solar panel. What is a bifacial solar panel and how efficient is it compared to a standard solar panel? That's what we're going to find out in this video. What struck me first about this solar panel is the size and the weight of this solar panel. Let me first show you the dimension of this solar panel. It's 40 inches long and it's exactly 18 inches wide, 1 3/8 of an inch thick, or about 3.5 centimeters. And it weighs a whopping 10.5 pounds, or about 4.7 kilograms. Here's everything it comes in the box with the solar panel. Just a piece of foam on the glass side to protect the glass of the solar panel, and then a user manual booklet. That's it. On the back of the panel we have MC4 connector and wire that's about 3 feet long or about 1 meter long. The solar cells are black monocrystalline cells. There are 4 cells this way, 9 cells that way, for a total of 36 cells. Here is the label on the front of the solar panel, and it has all the specs of the solar panel. This label is usually on the back of the panel, but for this one, it's on the front. And I just peeled this off right here, so I don't know how all of this text is going to hold up in the sun because it's facing the sun directly. A bifacial solar panel is one that can produce power on the front and also on the back side of the solar panel. And that means they have clear glass on the front and also clear glass on the back of the panel. Here's the front of the solar panel, and you can see the tapping wire on the solar cells. On the back of the panel, we've got also the same thing is happening. We got the tapping wire on the solar cells so that it will transmit power. And because it has clear glass on both the front and the back of the panel, so if I shine the light through, you can see the light can pass through, and that will allow the bottom part of the panel to absorb this light to increase the power. Just for size comparison, this is a 100 watt monocrystalline solar panel, but it's made in 2001, so it's about 23 years old. This one is the new eco-worthy bifacial solar panel. It's also a 100 watt monocrystalline panel, and you can see the size difference. This panel is exactly twice the size compared to this one. It's amazing how efficient today's solar panel is. And that is very small and lightweight for a 100 watt solar panel. Let's do a quick test and find out whether this is 100 watts or not. So right now I have the panel connected directly to the battery. I don't want to use a charge controller here because I want an optimum test. This test is going to be just for a few minutes, so it's not going to be overcharging my battery, so there's nothing to worry about. And as you can see, the solar panel is upside down, so only the back side of the panel facing upward, and it is in the shade right now. And we are getting 0.5 amp going to the battery. That's amazing. I'm going to put it in the sun and see what we got. Alright, so right now we're in full sun, and check this out. 2.5 amps at 16.6 volts. And the solar panel is facing down. That's amazing. So yes, the back side of the solar panel does produce power up to 2.5 amp at 16.7 volts, and that's about 50 watts just from the back side of the solar panel. That's amazing. All right, so I'm gonna flip the solar panel around and see what we got. About 3.8 amps at 17 volts. And if you take 3.8 amps times 17, that's about 65 watts. And that is the output from just the front side of the solar panel. So if you live in a solar system that has 2 suns on 2 sides, and you put a solar panel right in the middle, where the solar panel receives sunlight from both sides, then you can theoretically get about 110 watts. Now let's test on the effects of shading. So I'm just gonna cover up one solar cell here. See what we got? So it goes down from 3.8 amps. Now it's down to 0.7 amps. So there you go. If you only cover up just one cell, it will reduce the solar panel output down to only about 20%. And because we only have one sun in this solar system, I'm just gonna use it normally as it should be used. So I have the solar panel here, and on the ground I have a piece of white foam. It's gonna reflect the sunlight back up to the back side of the solar panel. So right now it's in the middle of summer and the sun is right above me, and that's not ideal because you want to have an angle where you can reflect the sunlight back to the back side of the panel. But I'm going to use what I've got here. So right now we're at 3.8 amps and 17 volts. Let's see what happens when I move the panel right above this piece of white foam. Alright, here we go. 4 amps. Exactly 4 amps. I try not to shake the solar panel here. Yep, 4.1 amps at 17 volts. So there you go, 4.1 amps at 17 volts when both sides of the solar panels are exposed to the sun. And if you take 4.1 times 17, you get about 70 watts. So it's been a couple hours and the sun right now is at an angle. You can see my shadow right there. I want to give this solar panel a fair chance. So let's do another test, this time at an angle. So the panel is angled so that the back side of the panel is facing concrete here. The concrete does have some reflection, even though not too much, but much better than last time when the sun is right above the head. All right, I'm going to go ahead and hook it up. We got about 4.1, 4.2 amps at 16 volts. It's not much better than before. Well, the solar panel is on the ground, so there's not a lot of reflective surface on the bottom. So let's try something different. All right, I got Junior holding up the solar panel for me because I don't have a ground mount for this. And the panel is way off the ground. And check this out, I still got 4.2 amps at 17 volts. So it's still the same. It's not better. So what if I have a reflective surface on the back of the panel? So here it is. This is a piece of foam insulation. One side of this is aluminum, the other side is just a white plastic. Let's see if it makes any difference. All right, so the aluminum foam is on the back of the panel now. Let's see what we got. 4.5. We got about 4.5 amps at 17 volts. And that's with a very reflective surface on the back of the panel. So far I can only get up to about 65 to 70 watts, and that's because this battery is only 17 volts. If you take a look at the specs on the panel, Vmax is at 20.2 volts when it's under load at 5.2 amps, so that's how we can get up to 100 watts. So what if I replace the lead acid battery with another battery that can go up to about 20 volts? Am I going to have a higher output with a higher voltage battery? Over here with my setup, I've got a lithium ion power tool battery here. This is a Black & Decker 20 volt battery, and it is a 5S battery pack, so it's 5 cells in series, and it can go up to 21 volts at full charge. And here I hook up the panel directly to the battery, and check this out. The charging voltage is almost 21 volts, but the current output is only 1.5 amps. 1.5 times 20, that's about 30 watts. So no, hooking up to a battery with a higher voltage does not give me a higher output from the solar panel either. So there you have it, EcoWorthy 100 watt bifacial monocrystalline solar panel. That's a mouthful. The only way I can get 100 watts out of this solar panel is to face the sun, both the front and the back of the solar panel at the same time, which is impossible. So if you put this panel straight on a flat surface, light doesn't pass through from the back of the panel. The maximum you can get is about between 65 to 70 watts. And even with my setup, when I put an aluminum surface on the back of the panel, I could only get up to between 70 to 75 watts. I figure you could probably get more than that if you have mirror on the back, way back, and then you shine light toward the back of the panels, and that will make it more efficient. But as the sun moves across the sky, the lights will change, and therefore it's not practical either. And I think because the solar cells can produce power from the backside, they expect you to install the solar panel in a way that you can get light from the back of the solar panel also. And because the solar cells on this panel is so efficient, this is actually the smallest 100 watt solar panel I have ever had. It's only 18 inches by 39 inches. Very small. So even though I can't get 100 watts out of it, I really like the smaller form factor, so it makes it portable and easy to carry around. And that's all for now, folks. Thanks for watching, and I will see you next time.